Namaste. I heartily welcome all of you to second year chemistry. In the first year, we looked at a lot of chapters in the three areas of chemistry: physical chemistry, inorganic chemistry, and organic chemistry. In organic chemistry, we got introduced to the basic concepts involved, what are the various effects that are involved in reaction mechanisms, how to name organic compounds, what are the different kinds of organic compounds that are known to man, and their classification. We looked at the three basic types of saturated compounds and unsaturated compounds: alkanes, alkenes, and alkynes. We looked at how to prepare them, the various properties involved, and the uses. We also looked at the compounds which have a benzene ring. These compounds are called as aromatic compounds, the preparation, properties, and the chemical reactions. In the second year, we'll continue from where we stopped in the first year. We will continue from compounds after alkanes, primarily involving functional groups. It is imperative that you need to understand the concepts of first year before you can really understand the concepts of second year. So my invitation to all of you before you start your preparation for second PUC is to focus on two important aspects of what you learnt in your first year. One, nomenclature. I want you to know the exact rules and regulations of naming a compound according to the IUPAC system. If they give you a structure, you should be in a position to write down the name. If they give you the name, you should be in a position to write down the structure. The second, I want you to go back and revisit the chemical reactions that you studied under alkanes, alkenes, and alkynes, and make a list of all the reagents that you have come across so far. Like finely divided nickel, it is used for hydrogenation. Anhydrous aluminum chloride, it is used in Friedel-Crafts reaction. Ferric chloride, it is used in chlorination. So like that, you came across a lot of reagents or catalysts. I want you to make a list of all these catalysts and reagents and write what they do in a chemical reaction. So these are two things that are mandatory revision concepts that you need to do before you start your second PUC syllabus. I hope you'll go back and revise all these concepts so that it becomes easy for you to understand the concepts that we will teach in second year. Now, coming to second PUC, I've already told you that we will be continuing from where we stopped in the last year. We will take few compounds based on the functional groups. We will study them, we will understand them, we'll try to see how they react and their uses. That's the way in which we will proceed. The first chapter under the organic chemistry that we will study this year is haloalkanes and haloarenes. Now, whole through this year, we will be going through a flow with the content. There'll be a particular way in which we will go with the flow. The flow will be like this. And this is a flow that is common for all the organic compounds that we will study. We will first address the question what these compounds are. What are they? Their various types and the various methods involved in classification. Once we have understood what these compounds are, then we'll ask the question how. Under how, we will try to look at how to name them, and we will try to look at how to prepare them. Once we have known how to prepare them, the next question that arises is why do we need to study them? We study organic compounds for basically the properties, the various chemical properties which give rise to various compounds which are useful to man. We will finally end with the uses of these compounds that we have understood so far. So this will be the brief flow in which the content would go and the way my classes will proceed. And this content flow is common for all the compounds that we would study in the second year organic chemistry. Coming to the first question, what are these compounds? Haloalkanes, haloarenes is what we've introduced. The question is, what are these compounds? Now, for understanding what, I will give you two structures. I want you to look at these two structures and find out what is the difference between these two and what is the common link between these two set of compounds. Are you ready? Here you go. So I've given you two compounds here, or the general formula of two compounds. I want you to look at these two and find out the similarities and find out how they are different. I'll give you a couple of moments so that you can observe and assimilate. Yes, we have studied when we looked at the periodic table and the various atoms that X basically stands for halogen. So if the moment I write X, it indicates halogens. It can be any of the halogens: fluorine, chlorine, bromine, or iodine. So when I look at these two compounds, compound 1 and compound 2, the similarity is the halogen. Clear? This is what is similar between these two compounds. Now, what is the difference? Difference is, here I have written something called as an R group, and here I have a benzene ring. So the basic difference between these two compounds remain: who is that halogen bonded to? What is that R group? Whether it is an R group which is alkyl, or whether it is a group which is benzene. So based on these two differences, we have haloalkanes and haloarenes. Now coming to the first one, this is the general formula of a haloalkane, which means R should be an alkyl group. If a halogen is attached to an alkyl group, then the resultant compound is called as a haloalkane. And what about this one? A halogen is attached to benzene. Compounds having benzene are also called as aromatic compounds. They're also called as arenes. So this is nothing but my haloarene. If a halogen is attached to a benzene ring, they come under the class of compounds called as haloarenes. So this addresses our question, what these are. If I have to put these in words, who are haloalkanes? Haloalkanes are nothing but halogen derivatives of alkanes. So who are haloalkanes? They are nothing but halogen derivatives of alkanes. Now what do I mean by a derivative? It means it is obtained from this compound by introducing a halogen. So if I take a alkane, to a alkane, if I introduce a halogen, then the resultant compound is called as what? It's called as a haloalkane. Then who is a haloarene? A haloarene is a halogen derivative of benzene. So benzene is my primary compound. From benzene, if I replace one or more hydrogens with a halogen, then I result in a haloarene. Clear? So to summarize, haloalkanes are compounds obtained when I replace one or more hydrogens of an alkane with a halogen. Haloarenes are those compounds which I get when I replace one or more hydrogens of benzene with a halogen. Clear? All right. So once we have understood what these are, we need to understand the types. What are the different types of compounds that are known to us? Now, I've given you a few structures here. I want you to look at each of these structures and find out what is the basis of the classification here. On what basis are they named, and what forms the basic understanding for this classification. I want you to observe all these structures. I'll give you a moment's time. Clear? Are you able to identify? Yes. So if you observe these compounds closely, this is related to this is related to this, and this is related to this. These three sets of compounds have a similarity. Now, what is the similarity? Yes, the similarity is the number of halogen atoms which are bonded. In these two cases, we only have one halogen atom that is bonded either to an alkane or to benzene. Therefore, this compound is called as a monohaloalkane. Mono means what? One. So halo means halogen. So these are compounds where I have one hydrogen of an alkane replaced by a halogen. Now, who is this alkane? C2H6. C2H6 is ethane. Now, from ethane, if I remove one of the hydrogens and replace it with a halogen, I get a monohaloalkane. Similarly, this is benzene. Benzene has 6 hydrogens. So, what have I done here? I've removed one of the hydrogens of benzene and introduced a halogen. The moment I do that, I get a compound called as a monohaloarene. So monohaloarene is a compound that is obtained when one or more hydrogens of one hydrogen of benzene is replaced by a halogen. Likewise, this is called as a dihaloalkane. Now, why is it called as a dihaloalkane? Yes, because there are two carbon atoms and two hydrogens have been replaced by halogen atoms. So there are two halogen atoms that is attached to this particular alkane. Hence, this is called as a dihaloalkane. When I look at this structure here, this is a dihaloarene because there are two halogen atoms which have been attached to a benzene ring. Coming to the third case, similar to the previous two, it's called as a trihaloalkane. Why? One, two, three. There are three halogen atoms which are bonded to an alkane. Likewise, this is a trihaloarene because there are one, two, three. Three halogen atoms bonded to benzene. So this is the first type of classification or first basis of classification. So what is it based on? Yes, it is based on the number of halogen atoms which are there in that compound. If a compound contains only one, then we call it as a monohaloalkane or monohaloarene. If it contains two, dihaloalkane or dihaloarene. If it contains three or more, we use a general term called as polyhaloalkane or polyhaloarene. So this is the first basis of classification. And what is it based on? It is based on the number of halogen atoms which are there in my alkane or my benzene. Then coming to the second basis. Now I want you to look at the three structures which are given here. I want you to observe, find out how are they different from each other. Look at these three structures, find out how are they different from each other. Yes, you're able to identify? Yes. When I look at the first structure which is given here, I have a halogen which is attached to a carbon, this carbon, which is in turn attached to one more carbon atom. Such a carbon is called as a primary carbon, and such a alkyl halide or such a haloalkane is called as a primary haloalkane. So who's a primary haloalkane? A primary haloalkane is a haloalkane where the halogen is attached to a carbon atom which is in turn attached to one more carbon atom. Such a haloalkane is called as a primary haloalkane, which is also indicated like this. Then coming to the second one, the halogen is attached to a carbon atom which is in turn attached to two more carbon atoms. Such a carbon is called as a secondary carbon, and such a haloalkane is called as a secondary haloalkane, which is also indicated like this. Clear? Coming to the last one. In the last case, the halogen is attached to a carbon atom which is in turn attached to 1, 2, 3. It's attached to 3 more carbon atoms. Such a carbon which is attached to 3 more carbon atoms is called as a tertiary carbon, and a haloalkane that is obtained is called as a tertiary carbon atom. Now, this is a very important concept. I want you to understand this because this keeps repeating throughout your various chapters. So it's important that you understand what is meant by primary, what is meant by secondary, and what is meant by tertiary. So what is the basis of this? The basis of this classification is the nature of the carbon atom containing the halogen. So what is the basis? The classification is based on the nature of the carbon atom which contains the halogen. Now I can have three types of such carbons: primary, secondary, and tertiary. Now who is a primary haloalkane? A primary haloalkane is a haloalkane where the halogen is attached to a carbon which is in turn attached to only one carbon atom. Such a carbon is called as a primary carbon, and such a haloalkane is called as a primary haloalkane. And coming to this case, bromine or halogen is attached to a carbon which is in turn attached to two carbon atoms. Such a carbon is called as a secondary carbon, and such a haloalkane is called as a secondary haloalkane. Then coming to the third case, the last case, the halogen attached to a carbon which is in turn attached to 1, 2, and 3 carbon atoms. Such a carbon is called as a tertiary carbon, and the haloalkane is called as a tertiary haloalkane. So based on the nature of the carbon atom containing the halogen atom, we have primary, secondary, and tertiary. Now, based on the nature of the carbon that contains the halogen, we have three more types. I've given the structure of these three. I want you to observe these three compounds and tell me how are they similar and how are they different. I want you to observe these three, find out how are they different and how are they similar. Got that? Yes? Yeah. Now the similarities are all the three of them have the same halogen atom, which is chlorine. Correct? What is the other similarity? The other similarity is all three of them are unsaturated compounds. Now, what are unsaturated compounds? Compounds which have a multiple bond. Now, this compound has a double bond. Here I have benzene ring where there are three double bonds. This compound also contains a double bond. Now, coming to the differences. Now, how are they different? Yes, they are different based on to which carbon the halogen is attached to. Now, the halogen is attached to this carbon here. Now, this is the carbon. Okay. What about here? The halogen is attached to this carbon here. What about this one? The halogen is attached to this carbon here. Now I want you to look at the three dots that I've drawn, clear, and find out how each one is different or how there is some similarity. Now when you observe the three compounds that are here, this one and this one look similar. Now how do they look similar? They look similar because the halogen is attached to a carbon which is only having single bonds around it. Therefore, this is a sp3 hybridized carbon. What carbon is this? sp3 hybridized. Same way, this halogen is also bonded to this carbon which has only single bonds. So this is also what? This is also sp3 hybridized. Whereas, look at this case, the halogen is bonded to a carbon which is having a multiple bond. And which bond is that? It's a double bond. So this carbon is an sp2 carbon. Now remember, we spoke about sp2, sp3 in hybridization last year. Last year there was a chapter called as chemical bonding where you understood something called as hybridization. If a carbon is surrounded by single bonds only, then the hybridization is sp3. If a carbon is surrounded by a double bond, then it is sp2. If a carbon is surrounded by a triple bond, then the hybridization is sp. Now we looked at that in the last year. We also looked at writing the structures of alkanes, alkenes, and alkynes, which included hybridization as well. You remember that? If you don't, go back and revise that because that concept becomes important for your second year. Clear? Now coming back to this concept. Now based on the nature of the carbon, whether the halogen is bonded to an sp3 carbon or an sp2 carbon, or whether it is attached to benzene, we have three more types. This type, what I've written here, in this case, the halogen is attached to an sp3 carbon atom, which is in turn attached to an sp2 carbon atom. Now this carbon is sp2. Clear? So halogen is attached to an sp3, which is in turn attached to an sp2 carbon. Such a halide is called as allylic halide. What is such a halide called? Yes, it's called as a allylic halide. Then what about the second case here? Halogen is attached to a carbon which is sp3, and that carbon is attached to benzene. This carbon is what? This carbon is sp2. Clear? Similar to this case. Okay, but this sp2 carbon is involved in a benzene ring. Unlike here, this is an open chain, this is a closed chain. So if a halogen is attached to an sp3 carbon and that carbon is attached to benzene, then such a halide is called as a benzylic halide. Clear? So this is allylic, this is benzylic. And coming to the last case, the halogen is attached to an sp2 carbon directly. Such a halide is called as a vinylic halide. What is such a halide called? Yes, it's called as a vinylic halide. Clear? So first one is allylic, second one is benzylic, third one is vinylic. Let me give you definitions for that. What are allylic, benzylic, and vinylic halides? Allylic halide or benzylic halides are those where the halogen is attached to sp3 carbon next to a C double bond. Clear? So a halogen is attached to an sp3 hybridized carbon but next to a carbon-carbon double bond. So what is a vinylic halide? A vinylic halide is a halide where halogen is directly attached to sp2 carbon or the carbon that is having the double bond. So this is the difference between allylic, benzylic, vinylic. Now this is very important. We'll keep coming across this a lot in the future. So very important that you need to understand this. Clear? Yeah. Now once we have understood what these compounds are, our next question that we need to ask is how. Under how, we look at nomenclature. How do we name these compounds? Now we've already understood this in detail last year, but we will also be going through each one of them this year again. Now we know that every organic compound has two names. Which are the two names? Yes, IUPAC name and the common name. We looked at the IUPAC system and the common system or the trivial system of nomenclature last year. Now let us try to understand how we name these compounds under both the systems. Let's look at IUPAC system. In the IUPAC system, the term haloalkane is given. So haloalkane is basically the IUPAC name for such compounds. The IUPAC name for haloarenes is halobenzene. So depending upon which is that halogen, we will be calling it as halobenzene. So let me repeat. Under the IUPAC system, haloalkanes are called as haloalkanes. That's what is the IUPAC name. Whereas haloarenes are called as what? They're called as halobenzene. Let's look at the common system. In the common system, haloalkanes are called as alkyl halide. Clear? Now remember the general formula of haloalkane is what? Rx. Now here the alkyl group is nothing but this. This will be named first, followed by the halide. Now if this is CH3, then what is that R group? Yes, it is methyl. So this compound will be called as methyl halide. If this is chlorine, methyl chloride. If R is C2H5, then what is the name of that alkyl? Yes, it is ethyl. So therefore, this will be called as ethyl chloride. If R is C3H7, what is the name of that alkyl? Yes, propyl chloride. So like that, I will be naming the compounds. So propyl chloride, butyl chloride, pentyl chloride, hexyl chloride, and so on. Whereas the same compound, how is it named in IUPAC? We will first name the halogen and then the alkane, named as haloalkanes. So if this is CH3 and I have Cl, how do I name it? Chloromethane. Good, because CH3 is obtained from which alkane? CH4, which is methane. So chloromethane. If R is C2H5, chloroethane. If R is C3H7, chloropropane. If R is C4H9, chlorobutane, and so on. So chloropentane, chlorohexane, chloroheptane, and so on. Clear? So now we understand how to name halogen derivatives of alkanes. Under IUPAC system, they are named as haloalkanes. Under the common system, they are named as alkyl halide. Whereas when you look at aromatic halides, now this is a benzene ring. This does not look like a benzene ring because I'm finding it difficult in writing the structure with the mouse. I hope you bear this. Now these compounds are called as halobenzene in both IUPAC as well as common system. So we do not have any separate way in which we name them. So the term halobenzene is used commonly. So if I have to name this compound, chlorine is attached to benzene, so therefore the name of this compound will be chlorobenzene. Clear? So in summary, haloalkanes are nothing but halogen derivatives of alkanes. Now, how do we name these compounds? We name according to IUPAC system as haloalkanes and according to the common system as alkyl halide. Whereas haloarenes in both IUPAC as well as the common system, they are named as halobenzene. Clear? If you have really understood this, I want you to name these compounds in both IUPAC as well as common system. So I want you to write each of these structures down. First, I want you to write the structures. This will be your homework for today. So I want you to write all these structures down in your book, and then write the common name as well as the IUPAC name for these structures. So I'll give you some time to write these structures down. Done? I'll give you 5 more seconds to complete. You want some more time? All right. So since this video is anyways going to be available with you, you can make a note of these structures even if you have not copied down fully. So what we will do is we will stop the class for today here. I want you to complete the homework in a book, take a picture of that and submit it. The details of submission will be intimated to you. So make it a point. You submit your homework in time. Clear? All right. So we will continue from where we stopped today in the next class. Until then, revise all the slides that we have studied so far so that you do not forget it. One piece of advice to you in the first class: organic chemistry is highly volatile. Now, what do I mean by that? It means it can get evaporated quickly. You will forget it very quickly if you do not practice. So, whenever you get time today, keep aside half an hour to practice whatever we have done so far, and you need to do it on a daily basis. Otherwise, you will understand in the class. The moment you go back and try to recollect it, you would have forgotten it already. So take this advice and ensure that you study from day one. Until the next class, thank you. Namaste.